today. Early question: will materials survive in space? 1940s to 1950s. When scientists in the 1940s and 1950s began planning space travel, one major question worried engineers. Open quote, "Can metals, paints and plastics survive the extreme conditions of space?" Close quote. Space is not like Earth. It has no air, vacuum, extreme heat and cold, intense radiation, atomic oxygen, micrometeoroid impacts. Early rocket programs in the United States and the USSR discovered that ordinary Earth materials cracked, melted, faded, or became brittle when exposed to near-space conditions during high-altitude tests. These early failures forced scientists to begin systematic space materials research. First real space discoveries, 1960 to 1970. NASA and the first US spacecraft. When NASA launched its first satellites in the early 1960s, scientists noticed surprising damage after retrieval. Paints discolored and peeled, plastics became brittle, metals showed surface erosion, rubber seals cracked. This proved that vacuum and radiation were directly changing the chemical structure of materials. Soviet discoveries, USSR. At the same time, the Soviet space program, USSR, also recovered satellites and confirmed aluminum oxidized. Strangely, thermal coatings failed. Plastic wiring insulation degraded. By the late 1960s, both superpowers agreed. Open quote, "Materials that work on Earth often fail in space." Close quote. The Skylab era. First major exposure experiments, 1973 to 1979. The world's first true space laboratory, Skylab, changed everything. NASA placed hundreds of samples of aluminum, steel, titanium, paint coatings, polymers and plastics outside the station for long exposure. Major discoveries from Skylab: oxygen destroyed paints layer by layer, plastics lost flexibility and cracked, metal surfaces eroded slowly in low Earth orbit, sunlight UV radiation caused rapid fading and chemical breakdown. This was the first long-duration proof that space actively eats away at materials, not just passively damages them. The Long-Duration Exposure Facility, ELF, breakthrough, 1984 to 1990. One of the greatest experiments in history was the Long-Duration Exposure Facility. It was launched in 1984 and stayed in space for almost 6 years before being recovered in 1990. It carried over 10,000 material samples, including 1. Metals, aluminum, stainless steel, titanium, copper alloys. Discoveries: atomic oxygen caused measurable erosion, surface roughness increased, protective coatings were essential. 2. Paints and coatings, thermal control paints, reflective white coatings, black absorptive paints. Discoveries: paints lost reflectivity, colors faded rapidly, some paints peeled off completely, thermal protection failed without UV-resistant chemicals. 3. Plastics and polymers, Teflon, Kapton, polyethylene, nylon. Discoveries: plastics became brittle, molecular chains were broken by radiation, mass loss occurred from outgassing, some plastics shrank and warped. These results completely transformed how spacecraft are built today. Discovery of atomic oxygen damage, 1980s present. One of the most important discoveries ever made was the effect of atomic oxygen in low Earth orbit. Atomic oxygen moves at 8 kilometers per second, strips atoms from surfaces, reacts violently with paints, plastics, rubber, some metals. It was discovered to be the main cause of surface erosion on satellites, solar panels, space station modules. This discovery forced engineers to develop protective coatings, silicon-based layers, gold and ceramic shields. Mir and International Space Station Studies, 1990, present. Mir, the Russian space station, Mir conducted many materials exposure tests and confirmed metals corrode slowly in space, plastics darken and crack, coatings must be constantly replaced. International Space Station, ISS. Since 2000, the International Space Station has continuously tested solar array coatings, exterior metals, spacesuits, paints, plastics for future missions. Key modern discoveries: radiation changes the electrical conductivity of metals, plastics lose strength over time, white paints used for cooling turn yellow and brown, space debris causes microcraters in metals. Laboratory simulation on Earth. Today, Earth laboratories simulate space using vacuum chambers, radiation guns, thermal cycling, atomic oxygen beams. Scientists now predict how long a material will survive, when it will crack, when it will lose strength, when it will fail completely. This allows companies to design satellites that last 15 to 30 years, spacesuits that protect astronauts, heat shields for Mars missions. Why these discoveries are important? The discovery of how space affects materials has allowed safer spacecraft, longer satellite life, reliable space stations, better thermal protection, stronger space